Okay, welcome to lecture 8.2. Okay, so thinking about how to do this media bias paper, and here's one thing that it seems like an obvious idea once you look at it. It doesn't seem that big an idea, but later on, I've thought, this was actually maybe kind of profound, and maybe a big something I don't think we quite get credit for. And this is the idea to compare media content to politicians' speeches. Um, so that's what we do, and we published this paper 2005, had rough drafts of it in 2003, and lots and lots and lots of media studies do that now. Compare media content, articles, transcripts of TV shows to congressional speeches. And a lot of times these people won't even cite our paper. They're kind of left-wing people who hate us because we, said that the media had a left-wing bias, and so they're just refused to give any credit to Grosclose and Milo. But the key is, even though everyone does that now, no one did that before 2003. Somehow, this was, even though it seems like an obvious idea, no one did that before our paper. And I think lot of why did we do that? And I owe some credit to Keith Crable. So, who was my advisor during grad school. So, a lot of my work as a research assistant for him was reading congressional speeches in the congressional record. And so, um, we talked about the Crable Rivers paper. A lot of what happened there, the reason that paper exists is because Keith Crable was reading the congressional record, and he would have me do it as his research assistant. So I knew about these speeches, and I knew about all this content, knew about like some of the things they would talk about in these speeches, and so I think this paper might not exist if it hadn't been for that research assistant job that I did for Keith Crable. Okay, so now here's how this paper started. I started off thinking it had to do with the uh, when Republicans wanted to repeal what they called the death tax. Okay, so how much you have to pay um, when you bequeath stuff to your heirs. And the Democrats would never call it the death tax, they would call it the estate tax. And it was so strange, even. I remember Chuck Schumer, even one time, he got so caught up in not, and the Republicans would, I think it was the official name was called the death tax. And so people say, oh, no, you should call it the estate tax. I said, well, wait. If it's the official name of the bill is the death tax, maybe you should. But people like Chuck Schumer were so adamant not to say death tax. I remember one time he talked about he in his speech he was talking about when a death occurs and then when people have to pay the tax. And he said when the estate occurs. I think he forgot. So anyway, there's this controversy about the language that they use, and it occurred to me that that's like a roll call vote. You see, that tells you pretty much exactly how they're going to vote on this bill by just looking at the speeches, seeing whether they call it the estate tax or a death tax. And I thought, well, wait, then the same thing. If you look at the media and whether they call it the estate tax or the death tax, that reveals how the journalist feels in his or her heart. By the way, at the same time, something had happened again from when I'd been a research assistant for Keith Crable. Part of my job then had been to enter all these roll call vote scores, like the ADA, the National Farmers Union scores. There's just a host of these interest group scores that I was entering part of my job for Crable, and it got me thinking. And at the same time, I'm noticing these speeches, and often just from reading the speeches, you could tell whether they were Republican or Democrat without even knowing the name of the person. I remember this kind of intellectual exercise. Can I tell? And can I tell the person's ADA score just from reading the speech? And I remember doing the same thing in my classes. I'd see some of my professors and thinking, well, wait, can I tell what is his or her politics? And that idea had stuck with me for 20 years or so, and not even no wait, like 12 years or so. This is like 12 years after I've gotten my PhD. And so I thought, okay, let's look at the media accounts. So look how a journalist writes. And just by seeing the language that he uses, that often tells you something about what he feels in his heart. And I thought, I'd been doing the same thing with politicians in their speeches. Can you do the same thing with media outlets? So this is the idea. So I thought, okay, suppose that um, we have the ADA score of a politician, and then we have on the y-axis, whether you call it, so give them a 1 if they call it the let's call the estate tax, and then a 0 if they call it the death tax. And I bet let's see, estate tax, the data are going to look like this. People with high ADA scores tend to call it the estate tax. Low ADA scores call it the death tax. But it's not going to be exact. And then if you fit a curve, something like this, it's going to look like that. The probability, given your ADA score, probability you call it state tax or death tax. And then suppose we just looked at a media outlet and said, what percent of the time, or, given you have a journalist, what percent of the time do you call it the estate tax or death tax? And suppose that there's some outlet that calls it the estate tax 80% of the time. Well, here's what you do. From this graph, you'd say, okay, there's a point, 80% point. What's the best prediction of that person's ADA score? It might be 70 ADA score, something like that. So that was the idea. And I thought, well, okay, all we need is a bunch of these little cases for some issue, and where people call it different terms. And so the time David Primo was my research assistant, and I asked him to go through some of these speeches in Congress and try to come up with a bunch of different terms. We thought there'd be like loads of terms, but really there wasn't. That was about it. And I thought, well, that's not going to work. I thought this was going to be like nominate scores, where if I just use these different phrases or different words they call different issues, that would reveal their stance on the issue, and it'd be like a roll call vote. But we just didn't have enough cases where it seemed like it would work. And then, fortunately, because I had that job working for Crable, reading speeches, I knew that they often cited think tanks. So I knew that, and so I thought, okay, let's do something similar with think tanks. Suppose we just started pairing up think tanks, think tank A versus think tank B, treat that like a roll call vote, and do something similar. And then you do like nominate scores, where just your cites to the think tank, A versus B, C versus D. This is like yay and nay votes on different roll calls. That might work. That might do something, and we can give something like nominate scores to different media outlets. And the great thing, I started thinking about this, and then I thought, fortunately, I had read the McFadden paper. And so I knew the McFadden paper, that when people made choices of what transportation to take, it wasn't these pairwise choices. McFadden said, oh, there may be 6 choices you can do. And I thought, wait, there's something similar here. So maybe I don't have to pair up these think tanks. I just have a whole slew of them and treat them just like McFadden did with modes of travel. So that was the idea. Okay. So once I did that, I thought, okay, here, now we can write an equation for this. This is kind of simple now. You think this is just like the McFadden paper. And so what I did is I said, legislator I or media outlet um, gets utility. So person I gets utility J for signing. There's all various think tanks they cite. So it turns out we had 200. So suppose it's 200 right now. So uh, so the person cites think tank J. Their his or her utility is called this. Sometimes we call it like a valence term. So this is just like the quality or how well known that think tank is this AJ. Plus, there's another term, B sub J, which is we multiply that by the ideology of the person. So, and this is XJ, where that is the ADA score of the legislator. Okay, now here's what we're going to do. For the media outlets, we don't know their ADA score. But if we knew the AJs and B sub Js, then you could actually estimate an XJ for a media outlet. Okay, so that's the idea. So, no, wait, not XJ. It's X sub I. So it's legislator I or media outlet I. So if it's legislator, and then if it's media outlet, so it's U sub I, so media outlet M equals A sub J plus B sub J times, you know what, and for the paper, actually, I didn't use, I was going to write gamma, but instead I'm just going to write C sub M. By the way, another little story while I'm thinking about it. When we wrote this paper, at first we had alpha J, beta J, gamma, and once we wrote it, we realized we really didn't need to put many equations in it. Now, at first we were going to write likelihood function, but then we put in these utility functions, and then I'm going to say, here's the probability that someone cites it given these utility functions. Turns out we only had 4 equations in the whole paper, and we thought, let's keep it that way. Let's keep this. So this might be in a pretty good economics journal, and let's keep it so, one, there are very few equations, and then the second idea, let's not put any Greek letters in it. So I did that on purpose. That was my idea. So those are not alphas and betas, okay, the A, B's, and C's. So those are the utility functions, okay? So those are the first 2 equations in the paper. Okay, now, I told you, what if there's like 200 think tanks, okay? And so this is like 200 modes of transportation. And what you're going to do is have the legislator pick one of them. Say there's this exogenous event where he decides, oh, I'm going to cite a news out or a think tank. Which one do I pick? Okay, same thing for a media outlet. And okay, there are 200 total think tanks, and we're going to say, what's the probability? Then suppose the person picks, think tank 62. What's the probability that he'll pick think tank 62? So if we can get that, once we can have these probabilities, it's going to be pretty easy to write a likelihood function, okay? So we need those probabilities. Okay, so if you're watching this, what are you going to do? So far, we need an error term to talk. So far, there's nothing stochastic at all. There's nothing random in here. So we're going to put on an error term, and that's going to be random. What does the error term need to be? And what are these error terms going to look like? Okay, hit pause. You should be able to answer this. Okay, are you back? All right, you've already taken this class. It should be obvious, okay? The answer is we're going to do the McFadden trick. And so what that means is we're going to make the error terms distributed standard Weibull, okay, or extreme value. I never remember if it was 1 or 2. I think it's extreme value 1, if you like, if you're younger. But if you're born before 1966, something like that, you call it Weibull. So that's what I'm going to call it. So here's what we did. We're going to put on an error term, epsilon. No. I was going to say epsilon, but I didn't want any Greek letters. So it's E sub I sub J. And if it's a media outlet, E sub M sub J. Okay. So, and this is easy. So given this, so if we don't have the media yet, we're just talking about the case where it's a legislator, the probability legislator I cites J is equals. So this is unfortunate. I called that the error term E, and now I'm going to call it the exponent. So this is the Euler constant. Unfortunately, maybe that was bad. Maybe I should have used epsilon. But this is expa. So E to the A sub j plus B sub j times x sub I. Okay, this is the McFadden trick. You take E to the scene utility divided by the sum of all the e's to the scene utility for all the different choices. So we're going to have to sum over all the possible think tanks. And so I use J. It's probably cite J. Let's make it K. We're going to sum over, make K be the generic variable representing the different think tanks. So K equals 1 to 200 of E to the A sub K plus B sub K times X sub I. I'm not writing that very neatly. Okay, so that's probability media outlet cites. The legislator cites think tank J, and then probability the media outlet M cites J is just going to be a very similar term. It's just E to the A sub J plus B sub J times. And now we don't know that for the media outlet, we don't know his or her X. So these X is the ADA score of the legislator. So that's data. But instead, for the media outlet, we're going to estimate the C sub M. Okay, so C sub M, and that's all divided by summation K equals 1 to 200 E to the A sub J plus A sub K plus B sub K times C sub M. Okay, so those are just the probability terms. So from here, it's pretty easy. We're going to talk about the dependent variable, and that is the think tank that media outlet M cites or legislator J cites. Okay, and you can give the probability that that legislator or that media outlet cites J. This is it. Okay, from here it should be very easy to build a likelihood function. Okay, and okay, that's what I'm going to do. Okay, I think I'm going to stop here. Okay, so it's about 20 minutes. Let me talk a little bit more details about exactly how you implement that. And also want to talk about a couple identification problems. Okay, so I will see you there in lecture 8.3.